Hey there! Today we're diving into an interesting problem regarding the use of smart pointers in a binary search tree implementation. The problem arises when compiling with G++13 on Ubuntu 4.04.1 LTS, as a compiler tends to favor branching over branchless code, specifically Kmove. Our aim is to encourage the compiler to use Kmove for more efficient code execution. Let's talk about the solution now. By restructuring the node structure and utilizing an array of unique pointers, we can achieve better assembly code generation. The provided code showcases a new struct, sv_node, with an array of two unique pointers named child. The svec function operates on this structure, iteratively navigating the tree while minimizing branches. This approach leads to more optimized assembly code, enhancing performance significantly. Continuing with the solution, the revised assembly code for the svec function demonstrates a streamlined sequence of operations. Through careful manipulation of pointers and efficient comparisons, the compiler generates code that minimizes branching, resulting in improved performance. This method showcases how small changes in data structure and access patterns can impact the efficiency of the generated assembly code. In summary, by restructuring the node representation in the binary search tree and optimizing traversal logic, we can guide the compiler towards generating more efficient branchless code. This approach not only enhances performance, but also showcases the importance of understanding how code organization can impact compiler optimizations. Thanks for tuning in, and don't forget to subscribe, like, and comment below with your thoughts. Remember, in the world of programming, even the smallest tweaks can lead to substantial improvements.